So as we have discussed in the last class, we have derived derivations for two explanatory variable model, and we have discussed if we add one more variable in the model, then is that my model becomes significant or not? Is there is any change in my model or not? Or is there is a any one can say r square value will increase or decrease like that? So these are the doubts we have in our mind. So to clear the doubt, the next topic is incremental contribution. Next topic is incremental contribution. So in incremental contribution, uh, we are discussing to understand whether if I'm increasing the any number of variable, should be should that variable is significant under the model or not. Okay, so suppose we have the coefficient of x1 x2 x. Instead of taking two variable, I hope you can able to see this. So the coefficient of x1 x2 are statistically significant different from 0 on the basis of t-test. So we have applied it above here t-test, and we have found that they are statistically significant. Now suppose we introduce x1 and x2 sequentially, that is we regress y on x and x's is significance, and then add x2 to the model, find whether it contributes anything or not. The order in which x1 x2 can be entered reverse. That means, so we have found that the model is significant on the basis of t-test. Now what I'll do, I'll take sequentially. Let me take y and x1 first. Let me take y and x1 and check the model. Then what I'll do, I'll add x2 and check the model. Then I'll add x1 and x2 both together and check the model. So is just adding the new variable or adding the given variable, is that my model is going to be changed or not? Is there is any significant difference will be there in the model or not? So those kind of things to be checked, we can always go for the incremental contribution. So by the contribution, we mean whether the addition of the variable to the model increases the explained sum of square or not. So as we have discussed, whether it is increasing the sum of squares or decreasing sum of square. Thus, the r square increases significantly. So here we have mentioned. So these I want to check. Okay, they are saying whether the addition of variable to the model increase the explained sum of square. So if it is increasing the explained sum of square, thus what can I say? R square increases significantly. Thus, this is called incremental or marginal contribution of explanatory variable. So let's see the procedure of this. So procedure of testing significant incremental contribution of explanatory variable, that is for two explanatory variable regression model. So whenever I'm go for testing, I will always check for H0 versus H1. So H0 incremental contribution of X2 is significant. So I'm just adding to the model X2, and usually we write this H0 will be not H0, right? Under H0, where it is null hypothesis, then we write it is not significant. So initially we assume this is not significant, and versus H1 it is significant. And here we prepare an ANOVA table. So in ANOVA table, I have source of variation due to x1. So x1 is already there in that model due to addition of x2. So I'm here adding the x2 variable, and again I'm adding both the variable together. So due to addition of x1 and x2. Okay, and this is the due to residual and this is the total. So how many degree of freedom we have in the case of x1. So we have in x1 it is the variable, it is the 1, because we have one coefficients. Then what about x2? Again we have 1. Here how many variable we are adding? 2, right? So here it is going to be, so this is going to be 1, this is going to be 1, this is going to be 1. This is because we are adding 2 variable, therefore degree of freedom is 2. Total how many variable we have total here? N minus 1, because n observation minus 1, we have a total n minus 1 degree of freedom. So if I take a difference of, if I take a difference of n minus 1 with, now this is due to addition of x1 and x2 total. So this, if I add up these two quantity, I'll get this quantity. So this minus this quantity is going to be n minus 3, n minus 3. What about TSS here? TS is equal to summation yi square, I is running from 1 to n. So this is already we have seen how to calculate, we have seen the last class. And then we have the formula for beta 1, that is your due to x1. So due to x1 we can call, let's say this is s1. So this is equal to beta 1 star square summation x1 I square, where I is running from 1 to n. Then if I take a difference of, let's say this is due to residual. So your addition, because this is the whole part is your ESS, right, which we have already seen. So this you can calculate, because this plus this you will get the due to x1 and x2. Okay, so this is nothing but ESS, which we have seen the last class how we can calculate. This is r square summation yi square, where I is running from 1 to n. So if I take a difference of this minus this, I will get this quantity. So this is ESS minus S1. And if I take a difference of this quantity minus this quantity, I will get this quantity. So it is, if I just take a difference this minus this, or I may write TSS minus ESS. So that is going to be 1 minus r square minus r square summation of yi square. I is running from 1 to n. And then based on that you can find MSS. Okay. So now since we have to check for the uh, incremental contribution of x2, so you need to calculate for MSS for only for x2. So just calculate MSS for x2. So this is ESS minus S1 upon 1, because to get MSS, S is upon degree of freedom. And based on that you can calculate FCAL. So FCAL will be 1 comma n minus 3. 1 will be degree of freedom this, and n minus 3 degree of freedom will be the residual. And for this one also we need to calculate. So this quantity I will be say RSS. So this you can call RSS by n minus 3, where here I will say where beta 1 star is going to be summation x1 I yi whole thing divided by summation x1 I square. So you can see the TSS which we have computed, it is similar to this one, and this RSS, or you can say this ESS which we have seen, this is again similar to this one. So if you have gone through this one, it is very simple to get for this one, okay, because it is the extension of your previous model only, and one can go with this beta one which you can compute using this formula.
सर
Yes, बोलिए.
रेसिडुअल का डिग्री ऑफ फ्रीडम n-5 आएगा ना?
No. See, if you just, this is your one variable, this is another variable, right? If you add
यस
this variable, we'll get this variable. This is
बट
this is
टोटल करेंगे तो n-1 नहीं आ रहा है ना, n+1 आ रहा है. अगर सबका टोटल लेते हैं मैं
आपको ये सब का टोटल नहीं लेना है. इसका टोटल मत लो आप, केवल ये टोटल लो आप. दिस वन. सी, ये जो वैल्यू है ना, ये ड्यू टू x1 ड्यू टू x2 एडिशन यू हैव डन इट, राइट? So
यस सर
here a plus b is equal to c, एंड जो c है वो मेन है आपका, बिकॉज c के बेसिस पे ही. सो इफ यू ऐड दिस टू क्वांटिटी, इफ यू ऐड दिस टू क्वांटिटी विल गेट दिस क्वांटिटी. सी,
ओके ओके
सर वो एसएस में S1 के बारे में बताओ ना सर, वो कैसे आ रहा है?
कौन सा?
सर S1.
दिस वन.
हाँ
दिस इज बीटा वन स्टार स्क्वायर समेशन एक्स आई स्क्वायर. ये कैसे मिलेगा आपको? सी, दिस फॉर दिस यू नीड टू x2 you have to remove, x2 you have to keep constant and do entire derivations for x2. Like if you just go through your previous one, let's say where's my beta one? I think this is the beta one, right? Okay, so if you say x2 will be 1 here, x2 quantity is 1, right? Is that turns out to be your beta 1? See that. So this is 1, this is 1, okay? Means actually I'm removing, because I am putting that x2 is a constant and trying to getting beta 1. So you come up with this part. You can come up with this part. See, you have seen for the, I think y on x का derivation ना, y on x का derivation में check for beta 1. I think that is the same thing we have computed here. अगर मैं रिग्रेशन इक्वेशन y on x का डेरिवेशन करता हूँ, तो उसमें जो x1 जो बीटा 1 मिलेगा वही है. आई थिंक वो बीटा 1 आपका वही है. Just check that beta 1 is same or not in that case, and again you can use that formula and get the value of x. See, this basically you need to compute this one, and s1 का formula ध्यान रखो, and do the subtraction, we will get this one. Why? Because we are testing for this one. जो addition x2 है ना, उसका हम लोग टेस्टिंग कर रहे हैं. So for that purpose we need to understand how this ESS can be computed, and TSS और RSS तो आपने already निकाला है previous derivations, so you can work on that. There is no problem. Then after this, since two unknown parameters, so degree of freedom for ESS is 2. See, now since we have two unknown parameter, therefore ESS degree of freedom is 2. One can say like this, but what I did, I have just taken addition of these two. See, if you add up these two quantity, I'll turns out with this quantity. But one can, if, see, this is all matter of how you are adding the variable. If I'm adding here x1, so if I'm adding x2 here, then the degree of freedom will be 1. If I'm adding one more variable, let's say again x3, again degree of freedom will be 1. So the total addition will be 3, and we have n minus 3, then it's become n. So it's based on the variable, how many variables we are adding. And then again the condition is same. If fcal will be greater than f1 comma n minus 3 comma alpha, then reject h naught and conclude that conclude that conclude that incremental contribution of x2 is significant. Similarly,
सर एच नॉट अपना एच नॉट क्या है सर?
h naught is,
देयर इज नो इंक्रीमेंटल कंट्रीब्यूशन ना?
yeah, for x2 variable, for x2. Similarly, one can test for,
ओके सर वो साइन शायद उल्टा है ना सर?
एक minute, let me just complete this, then I'll
सर एफ क्या
incremental contribution
सर वो जो
of,
रिजेक्शन क्राइटेरिया है सर वो उल्टा आएगा ना?
कौन सा,
साइन सर साइन उसका उल्टा आएगा ना मतलब सर?
किसका साइन,
सर
which
वो जो
sign,
रिजेक्ट है ना, रिजेक्ट एच नॉट,
this one, fcal greater than f
सर
वाला,
स्क्रॉल डाउन करो आप.
ये वाला,
हाँ सर.
हाँ क्या,
सर एफ कैलकुलेटेड लेस देन आएगा ना सर?
f calculator लेस देन आएगा,
हाँ मतलब सर नहीं 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 नहीं, सॉरी सॉरी सॉरी
हाँ
सॉरी.
ओके,
परफेक्ट सर.
बिकॉज अगर वो रीजन के बाहर ही आएगा तो ही आप रिजेक्ट करोगे ना, रीजन के अंदर आएगा देन
नहीं
यू हैव
मैं
टू एक्सेप्ट इट ना.
करेक्ट सर करेक्ट.
Okay. So similarly, you can do for incremental contribution for x1 also. See, that's why I have mentioned here sequentially. So you have to always go for sequentially. Assume x1 constant and do the addition of x2. Then again assume x1 will be constant and do the addition. Means vice versa. Okay. So one can go with this model. Due to x2, addition of x1. See the degree of freedom and this beta instead of S1, now you have a S, you can say assume S1 only, but here beta 2 star square into summation of 2 summation of x to I square will come in picture. That difference is only there in the case of x1. Okay, so just always remember those things which we can able to do it. Okay, so any other questions related to incremental model? Yeah, let me see the chat box also. If you have any questions, you can. So I hope I have given the answer for everyone. And when you calculate here, r square, then only you will be know whether your due to increasing or due to adding the new variable, whether your r square value increases or decreases. Okay, and this you can understand when you actually go for the problem of you can say numerical values. Okay, so that we will see in the when we will conduct the practical session. So let me know if you have any other questions related to incremental model. F calculate can be calculated ESS upon ESSE. F calculated. No, F calculated will be obtained based on the degree of freedom, right? So the degree of freedom for this one, which is for x2 and residual, that is based on that, not a ratio. Sorry. Yeah, correct. F calculated is based on, correct. F calculated is based on this one. We can call this criteria, this quantity divided by this quantity, right? This you can call M. You can uh, this is F calculated for, this will be MSS for x2. So I will say this is x2 upon MSSE. Okay, so based on this, that means this divided by this quantity, you will get the F cal. I thought it is L. I thought it is F. F cal. Okay. Okay. Any other question is there? How S1 is calculated in SS column? See, we have all data with us, right? We have all data with us. Like we have given the data on X, that is your x1, x2, xa, and so on, right? You take a summation of those quantities. Beta 1 you need to calculate using the formula given here. So you need to create a table, like we are creating for regression. Like we have done. I think we have also seen the problem, I think, in simple regression. सिंपल रिग्रेशन में आपने कौन कौन सा कॉलम बनाया है, x बनाया है, फिर y बनाया है, देन x into y बनाया है, देन x square बनाया है, and based on that you are calculating beta 1, and that beta 1 will substitute here into x1. So for a being we will assume it is x1. x1i का मतलब हम लोग उसको x1 assume करेंगे, और it is very simple procedure. We will see when we calculate when we go for the numerical values, then we can go with that. I hope you have this we have already seen in the regression model, simple regression model. Just see whether you have done it or not in the regression model. Let me check whether you have done it in that. See, you can check ना, simple simple linear model में आपने beta 1 calculate किया है already, I think. I don't have presently that notes, but if you just go to unit 2 and just find out whether you have just calculated this beta 1. I hope if you have a notes, you can able to see that notes. The same formula we are using here only. The only difference is there were not x1i. Only their difference was there were xi, yi. That difference is there only. That much difference is there. You can just check it out. It is there. It is there with you in the simple linear regression model. That means y on x. Check for the derivation of y on x. And then let me know whether you can able to calculate beta 1 or not. Okay. Any other question is there? Yes. Okay. So I got one response. We have seen the beta 1, how we have calculated. So this is related to your uh, we can call incremental contribution. Now this is the derivation for to explanatory variable and incremental contribution. And now we will go to so I'm now just opening the next file, which is actually, so the derivation which I just did now, I'm going to upload in Canvas. So you can download it, and you can try to write it down your entire notes, okay, and then start working on quiz based on the given notes. So far I have not uploaded the quiz, so let me just uh, upload first theory, start reading the theory part, and then we'll go to the quiz part based on that. So linear regression model with two explanatory variable we have seen the last class. That was this model, and we have derived everything, like, and we done the testing, and then we done the contributional model. Now let us go to the setup of your MLR, multiple linear regression model. So now I'm talking about if we have the variable x1, x2, xn. Okay, so we will discuss now general case. Instead of two explanatory variable, we have a k explanatory variable. Okay, so let us do the experiment conducted n times, and the data is obtained as follows. So this is the data based on the experiment done. So we have x1, that x1 is x11, x21, so on xn1, and this x, because it is a repeated measure, right? So x2 is nothing but x12, x22, and so on xn2, and so on. So this is the response model, this is the response data, and this is the explanatory variable. So how to do the model setup? So this is your model: y is equal to beta naught, beta 1 x1, beta 2 x2, beta k xk plus epsilon. But this x1 is nothing but your x11, x12. If you see if you see the previous one, this x1 is x12, x11, x21, xn1. So this x1 contain, again there is observations. Okay, see, so there are n tuples of the observation, means n number of observations we have are assumed to be follow the same model. See, this model follows, we know the all assumptions and everything we have already seen in the uh, in unit 2. Okay, so that assumption again we are going to I will just going to go through that assumptions. I can just work on this assumptions. So this x1 will be written as x11, x12, and so on x1k. So I'm assuming because there is k. Okay, so whenever there is k, it will change according to the formula, and then we can go with this model. So writing this, this is your general model. I have written if I have observations. Okay, I hope you can understand this because this is all we have already seen. So there are n equation and can be written as, so now I'm writing in terms of equations. Now I'm writing in terms of equations. So this is my equations. So y is equal to beta naught. This is your observations plus epsilon epsilon means all error term. So the thing is that the previous one which we have seen model, this one, this one, this equations. So these equations represented in a form of matrix. There is one thing is missing, I think. Just a minute. Uh, that is, I think it is down. Just a minute. This was missing. So share the screen. So above equations I have written in the form of matrix. So you can see the form of matrix. This is the y, your response variation, response variable. This is your constant beta 1 beta 2 beta k, and that is your equation actual data plus error term. Now these equations can be written in the form of matrix. So y is equal to x beta plus epsilon. Okay, so y is your these observations, x is your these observations, and beta is your these observations, and epsilon will be this. So here there where y will be, now this is little bit we have to understand the matrix form. Okay, so this is where y is y1 y2 yk is n cross 1, is n cross 1 vector of n observation on study variable. Okay, this is the study variable. Okay, so this is n minus 1. So here we have an n minus 1 observation. And if you see the x, if you see the x, so this was the actually you can say n minus 1 observation. How it is n minus 1? Can anyone tell me how it is n minus 1? Yes, anyone? How it is n minus 1 observation?
Sir, please repeat the question.
How it is, because y1 y2 yn, it is actually yn now. Just make correction, this is not k, this is y1 y2 yn. Okay, just just a minute. This is this is yn, this is also n. So we have y1, y2, yn. So how it is n minus 1 vector? Can you tell me? N rows, 1 column, na? We have n rows, 1 column. And I think it is also, yeah, this, I think this is K. This is correct. See, this is why I'm talking about, because we are doing with the MLR, multiple linear regression model. Working procedure for that is quite difficult. So that's why the whole thing can be converted in terms of matrix. Okay. So this entire data which I have converting in terms of the linear model. This is called linear model. Y is equal to x beta plus epsilon. So, but here we have to understand the order of your each observation. Each you can say variable, dependent, independent, coefficient, and so on. Okay. So since 1, 2, 3, 4 up to n.
सर वो
So
बीटा के जगह पे बीटा n माइनस वन आएगा ना?
beta either
n minus 1.
no, a correct,
Yes sir.
because we have a beta k na, you have the k regression model, because this is observations ना, ये तो आपका observations है ना. Okay.
Yes. Okay.
So if you just see the previous one, see this one, and x is nothing but this is your coefficient of beta naught. This is your coefficient of beta naught. This is beta 1. This is your beta 1. This is your beta 2, and so on. This is your beta k.
Yes sir.
So if you just, so what is the order of this one? So the mainly thing is why I'm going to very slow, because in MLR we need to understand only the matrix notations and what is their dimension. That is two things is very important in the case of MLR. Otherwise, rest is very simple. You have to just assume the one what you called one theorem, and based on that you can directly get the value of your beta naught. Not a problem. Only the thing is you have to understand their order. So here one can see this is the constant. Beta naught is a constant, right? And how many? First of all, how many rows we have? 1, 2, 3, so on up to n. So it is order is n into 1, 2, 3 up to k. So we have a k constant plus 1 extra. So it is k plus 1. Let me know whether you can understand the order or not. So is
Yes
n
sir.
into k plus 1 matrix of n observations on each of k explanatory variable, and beta naught is given this one. Beta naught is given this one is, see now, see you can see the order of this again, is a k plus 1 into 1. जैसे आपका y1 y2 yn था, it was n into 1. Similarly आपका जो बीटा होगा वो k plus 1 into 1 होगा. Why? Because beta naught is a constant, one extra variable, right? So it is plus 1 into 1, because we have a one column vector of a regression coefficient, and epsilon, which is epsilon 1 2 so on n, is n into 1, because this is same as your observations, vector of a random error component or disturbance term. So overall what I means to say, if I have equations, if I have equation, this is my equation, y is equal to x beta plus epsilon. Okay, So we know this y is n into 1 observations. Your x is n into uh, k plus 1 observations, and your beta is k plus 1 into 1 observations, and epsilon is n into 1. Okay, so if you just multiply these two quantity, क्या मिलता है? Multiplication n into 1. So we have turns it n into 1 is equal to n into 1 plus n into 1. That means your multiplication is absolutely correct. So we need to understand only this all terminology, which is important for us. Otherwise it is just a multiplication concept, and the whole thing you can do it in very few seconds. Is that clear to all? Let me see chat box. I think y is equal to matrix y is equal to x star. Yeah, see, that is all matter of using notations. So you can use x star, you can use x1, you can use x1 star, whatever you want you can use. But general model says like this. So you can use whatever you want. Only the thing is that you can understand this what x representing. You can use x star. That is also fine, no problem. Okay, that is not a problem. You can go with x star. You can go with x1 star. Okay, you can go with x star, no problem. The only the notations, only the order which I'm assuming here, that is important. And based on that order, you can always go with that. Is that order is clear or not? Everyone, if order is clear, then I'll proceed. Otherwise, I'll explain one again. So we proceed. Go to chat box and write down yes. Okay. So once you understand the model with their dimension, the next is, so this is the way you can always set up the model. Okay, this is the way you can always set up the model, and once you understand the model, we can go with their assumptions. I think this is the similar way you can done it in the simple linear regression technique. Okay, once you have set up the model, then we move to their assumption part. So again, I will not going to deal much about these assumptions because you have already gone through all assumptions in the simple linear. The same, it was the same assumption related to MLR also. Okay, so we have already seen the expected value of, that is, disturbance term is 0. Expected value of epsilon dash, you can say variance, it is a sigma square. Rank of x is k plus 1. Rank of x is k plus 1 because you have n into 1, n into, you have this one, right? uh, n into k plus 1. So k plus 1, observe what is the rank? Number of independent rows and column. So we have a k plus 1 number of independent rows and columns. Therefore the rank of x is k plus 1. Then we have a x is non-stochastic matrix. Epsilon follows, that is a disturbance term follows 0 comma sigma square in. So this is all assumption you have already seen in the SLR. So you can just go through that how it works. Only the, I think, rank we have not seen because the rank here we are talking about, because this is talking in terms of matrices. So that's why the rank comes in the picture. Otherwise rest you have already seen in the SLR. So again we are going to use the principle of ordinary least square concept. So that principle that we have already, I think, so many times we are dealing with that. So there is no problem. Let B be the set of all possible vector beta. So now I'm assuming the new quantity B, which contains set of all possible betas. Okay, set of all possible betas. And if there is no further information, then B is a k dimensional real equivalent space. अभी ये क्या होता है real equivalent space? See, whenever we're talking about the order of 2, okay, order of 2, then order of 2 मतलब कैसा हो जाएगा आपका? If I'm saying order of 2 means it is y 2 cross 1 uh, x. So x 2 into k plus 1, right? 2 into k plus 1 into beta 2 into 1 plus. So what I'm trying to say here, we have a space of we have a, instead of k dimensional, we have a 2 dimensional. Dimension is 2 means y1 y2 रहेगा. Similarly, we have a y1 y2 yn, and here we have x1 sorry, beta naught, beta 1, so on up to beta k. That's why there is a k dim, because this we assume this is nothing but your b, right? So this b is a k dimensional Euclidean real space. So this contain all basically talking. It is just matter of how you interpret the Euclidean space. So order 2 हुआ तो आप सिंपल आपका प्रीवियस मॉडल यूज करो, तो एक्सप्लेनेटरी मॉडल. के है तो के के लिए डिफिकल्ट होता है, इसलिए हम लोग क्या होता है, सी अगर आपके पास 2 क्रॉस 2 अगर आपके पास x और y है, you can very easy to plot the data for x और y का. बट अगर 3 है तो so you have to just imagine, right? So you have to, it is not possible to like draw for 3. तो सोचो अगर 3 है 4 है 5 है तो कैसे आप, so you have to just understand how it works in the Euclidean space. Okay, that is a small concept of Euclidean space, but that is not much required. You just understand. Then the object is to find b dash. So I'm a new notations I'm using. B dash is nothing but b1 b2 bk from b, and that minimizes the sum of the square deviation of epsilon. So that basically I'm using ordinary least square, so I'm minimizing error sum of square. So I hope you can able to see this screen. This is not very clear, but one can just understand. So S of beta is equal to summation epsilon I square, that is epsilon dash epsilon y minus x beta dash y minus x beta. Now we are talking about the in terms of matrix, right? तो आपका epsilon क्या है? Y, your epsilon is, what will be your epsilon? So y is equal to x beta plus epsilon we have, right? So epsilon become y minus x beta, right? So once we have epsilon, we want epsilon dash. So epsilon dash, तो dash हो जाएगा into y x beta. So that means I'm trying to find out the error term in terms of y, and a minimum will exist as s of theta is a real valued and convex and differential function. So it is similar in they're talking about matrix. तो मैं बोला ना फर्स्ट डेरिवेटिव इक्वल टू 0 है और सेकंड डेरिवेटिव आपका पॉजिटिव होता है, देन you can say that is the minimum. बट इस सिचुएशन में ऐसा नहीं होता है, इस सिचुएशन में आपको थोड़ा वर्कआउट करना पड़ता है. ओके, तो हाउ कैसे आता है वो आपको देखना पड़ेगा. तो इफ यू जस्ट एक्सपांड दैट y माइनस एक्स बीटा, तो एक्सपांड करेंगे तो कैसा होगा, y माइनस एक्स बीटा डैश है एंड y माइनस एक्स बीटा. तो इफ यू डू मल्टीप्लिकेशन तो कैसे होगा, देखो y प्राइम है तो y प्राइम विथ y, so you will get y prime y first term. Then see whenever you do prime of this, क्या आता है? It is beta prime x prime. तो पहले इसको प्राइम लेंगे, बीटा को प्राइम लेंगे, and then we go with the x prime. So it's become beta prime x prime. So first we multiplied this with this, and then we multiply this with this. तो क्या मिलेगा? X beta prime means beta prime x prime into x beta. So you get the second term. Now we multiply this with last quantity and first quantity with the second quantity. First quantity with first quantity. Okay. So how it multiplies? So if I just do multiplication, so this will y prime. It's a y prime. Okay. So y prime x beta, and here we have beta prime x into y. So it's a beta prime x prime y with minus sign. With minus sign. So if I add these two quantity, can I get this quantity? Just check it. Now there are several results which is not included here. Okay, but there are several results. This y prime is equal to y and beta dash prime is equal to beta. If I replace those quantity, so it is going to be y x beta prime, okay, minus, and even I can do for x prime is equal to x into beta prime x prime y. So that is going to be what now? Minus 2 times beta prime x prime y. तो ये सब रिजल्ट्स आपको मिलेंगे कहाँ पे? This is all basically you are going to deal in the masters level. Okay, so just understand how this calculation done. So there is some standard results. If you want, I can able to send the peak of the same. Okay, you can just go through that. Okay, so I think in this case there will be no problem, but only the thoda little bit problem is there, but you can use these concepts and you can go with that directly. So you have to differentiate this quantity with respect to beta, and if you differentiate this quantity with respect to beta, so first term is 0, right? So as I mentioned, beta dash and beta both are, both we can take it is beta, right? Because beta dash and beta both are same, and if it's a beta square, so 2 times x prime x into beta minus, again this is the beta, so 2 times x prime y. So if you differentiate, you'll get this. Your second derivative will be this one, because this is 0, so this quantity is positive, right? At least non-negative definite, uh, def, definite. So we can say this is positive. So if this is positive, and we know the normal equation is this equate with 0. If equate with 0, that means this entire thing is equal to 0. Now you can see this beta I have replaced by b here, and based on this b, one can get x prime x inverse x prime y, but you cannot get this directly because you have to use the results which is there. So this result is important. This result is important. So So again, this result will be quite difficult because understanding itself it's very difficult. So if we have the any function, any quadratic form, this is called quadratic form. Okay, so f of z is equal to z prime az is a quadratic form, and where z is a m cross 1 vector and a is any m cross m symmetric matrix, then if I differentiate this quantity by z, it will come up with 2 times az. जैसे हमने ऊपर देखा कि ये इक्वेशन में देखा ना, इन दिस केस, ये केस में देखा ना हमने क्वाड्रेटिक फॉर्म है करके, या फिर ये केस ले लो आप, कोई भी केस ले लो, बीटा डैश ए बीटा, इसको डिफरेंशिएट करोगे तो ये कैसे मिलता है, तो वो रिजल्ट वो बता रहा है, मीन्स ये जो फॉर्म है देयर हैज टू बी सम क्वाड्रेटिक फॉर्म, देन ओनली you can use that result, otherwise you cannot use the result. So if you have this form, this quadratic form with this order, then if I differentiate this f of z, that is a quadratic form with respect to z, it may give result a time 2 time az. So if what I mentioned here, if I am assuming this z dash becomes z, so it's become z square, so a z square, simple सोचो आप, ज़्यादा डीप में मत जाओ, अगर मैट्रिक्स आप भूल जाते हो और z dash को आप z अज्यूम करो तो ये z स्क्वायर हो जाएगा, और विद रिस्पेक्ट टू z डेरिवेट करोगे तो आपको क्या मिलेगा, 2 टाइम az मिलेगा. So same concept you can use, since it is assumed that rank of x is k, फुल रैंक है, अपने केस में k plus 1 है, बट इनके मतलब दिस इज सम रिजल्ट, स्टैंडर्ड रिजल्ट है, then x prime x is a positive definite, we have seen just now x prime x positive definite, and a unique solution of a normal equation is this, which is termed as OLSE, which is ordinary least square estimator of beta, since your second derivative is at least non-negative definite, so beta is a minimum of s of beta. So ये रिजल्ट के बेसिस पे हमको ये जो प्रीवियस में है, इधर ही करेगा तो
हेलो सर.
यस बोलिए, एक मिनट मैं ओपन कर, बोलिए. ये तो ये थोड़ा सा
सर वो जो मैट्रिक्स है ना सर, y इक्वल टू,
हाँ, ये वाला इधर, विच वन, दिस वन,
नो सर, वो जो डायग्राम आपने बनाया था ना सर, सर वहाँ पे बीटा आपने पहला लिखा है, बीटा एक्स लिखा है सर, वहाँ पे एक्स बीटा आएगा
कहाँ पे,
सर, पीछे करो.
एक
जहाँ पे सर आपने मैट्रिक्स पूरा बनाया ना,
एक इधर,
यस सर, यहाँ पर सर गया सर, एक्स इंटू बीटा आएगा ना सर, आपने ऊपर बीटा इंटू एक्स किया.
बेटा ये बोल रहे हैं आप, ये बोल रहे हैं,
हाँ सर, वो पिक्चर अभी एक आया था ना सर, पिक्चर. हाँ सर, पिक्चर में आपने बीटा इंटू एक्स किया है.
हम्म, हाँ,
यस सर, देखो.
आप इसका ऑर्डर चेक करो, ऑर्डर इंपॉर्टेंट है, आप x इंटू वाई लिखो, जस्ट अ मिनट,
सर नहीं आ रहा ना सर वैसे.
एक मिनट, देखो अभी आपका ऑर्डर देखो, इसमें बीटा का ऑर्डर क्या है तुम्हारा, यहाँ पे इट इज k plus 1
इंटू वन.
into 1, राइट, और x का ऑर्डर क्या है तुम्हारा,
यस सर.
x का ऑर्डर क्या है, n into k plus 1 है ना?
यस सर।
तो मल्टीप्लिकेशन हो सकता है क्या? हो सकता है, देन इट इज करेक्ट। नहीं हो सकता है मतलब, तो ऑर्डर इसका क्या मिलेगा? n into 1।
हाँ सर, बट इस केस में देखिए सर, आप n इंटू के प्लस वन को पहले ले रहे हैं,
अच्छा,
करके सर मल्टीप्लिकेशन पॉसिबल हो रहा है, और बीटा को आप पहले लोगे तो फिर सर नहीं होगा मल्टीप्लिकेशन।
इसमें इसमें होगा ना, क्यों नहीं होगा? आपका x का क्या
सर
ऑर्डर है
इसमें
इसमें
होगा,
जो?
सर इसमें होगा।
हाँ,
सर वो डायग्राम जो है ना सर, अभी डायग्राम
नहीं
जो आएगा ना, उसमें सर आपने बीटा पहले मल्टीप्लाई किया है, वो
नहीं, वो
कह
आप
रहे हैं।
बाद में, ये आप बाद में मल्टीप्लाई करो। हाँ, दिस यू दिस इज द स्टैंडर्ड
हाँ
फॉर्म,
यस
दिस
सर।
इज द स्टैंडर्ड फॉर्म। ओके, ये जो है आपको स्टैंडर्ड फॉर्म है। ये ना एक ये जो है ना आपका, वो स्टैंडर्ड फॉर्म है। अब कोई भी रेफरेंस बुक में देखोगे ना आप, तो आपको स्टैंडर्ड फॉर्म यही मिलेगा। दिस बीटा यू राइट डाउन हियर। हाँ, दिस बीटा यू राइट डाउन हियर ओनली, बीटा नॉट, बीटा वन, सो ऑन अप टू बीटा के। इधर लिखो आप, इंस्टेड ऑफ राइटिंग हियर, डोंट राइट हियर, राइट डाउन हियर, बिकॉज एक्स बीटा प्लस एप्सिलॉन होगा। एक्चुअली मैंने ये क्यों लिखा कि मुझे लगता है प्रीवियस, पीछे पीछे कैसा फॉर्म दिया है आपको? आई थिंक आई फॉलोड द प्रीवियस फॉर्म ओनली। यहाँ पे बीटा के फॉर्म में दिया। ओके, बीटा पहले निकला कर। ओके ओके, ठीक है, बट यू राइट डाउन द बीटा विल बी ऑलवेज दिस साइड। डोंट राइट हियर, बिकॉज अदरवाइज वो एक्स इसको जिम किया, बीटा इसको जिम किया। Fine. ठीक है, okay, so I know this is a little bit difficult, because you have to deal with uh, most of things with the notations, so that is quite not easy, but you try to understand and just go through that. So whatever update is there in this slide, I will make update first, and then I will upload in Canvas. You can work in Canvas, okay, and then we can go with that. There's no problem. Okay, so any other question is there? Any other doubt is there? So I think we have already done this one. Uh, Now we are left with only a few part of this multiple regression model. So then we'll finish this first, and then we'll go with the. So this is exactly same thing you did in the SLR, where you have estimated the coefficients, and then at the end you have prepared an ANOVA table, right? So the next class we'll do all ANOVA table and everything, and then this unit will be finished. This unit is not like, there is not much thing is there, because we are dealing with all derivation and everything. Okay, you can just go through that and let me know if you have any difficulty. अच्छा, chi square के बारे में हम लोग next class करते हैं, because now it is 11:06. So maybe this week we will try to finish this unit, and then whatever discussion we can able to do it, we can go with that. Okay, so because it is now 11:06, so maybe some students having some other working. Okay, Jyoti Pandey, I'm not talking about the notation. Acha, okay. I can't understand, then not talking about notation, then what? Okay, so we'll end the session if we do not have any query. And if you have any query, you can text me. There is no problem. I will, maybe not very soon. I will update, but whenever I'll get the time, I will update the your query. Okay. So have a good luck. See you on the next class.